Hi everyone and welcome to this video. This time I have an HP ProDesk 400 G5 Microtower here with me, and the idea of this video is to completely disassemble it, then reassemble it, benchmark it, and later also to upgrade the GPU from the currently installed NVIDIA GT 1030 to this NVIDIA GTX 1650. I already know that the GTX 1650 will definitely boost graphical performance on this machine, but I'm also curious to see what the GT 1030 can do as well. The HP ProDesk 400 G5 is part of the entry-level Pro Series desktops HP has to offer. It came on the market around mid-2018 and was equipped with 8th generation Intel Core CPUs and DDR4 memory. The model I have here has pretty decent specifications, as it has an i7 8700, 16GB of DDR4 and, as I already mentioned, an NVIDIA GT 1030. From the spec sheet we can see that this CPU is a top model for this machine. The GPU is not on the list, so I guess it got installed afterwards. I got this machine from an online auction and could pick it up in a pretty industrial environment, which was not the most clean place. As you can see, the front looked pretty dusty and greasy, but unfortunately the design of the machine did a good job, as most of that dirt stayed on the outside. Before I started, I obviously gave everything a thorough clean, and so here we are. The design of the machine is pretty much in line with other HP ProDesk and Elite desks from around the same time. In previous videos, I looked into similar machines like the successor of this one, the ProDesk 400 G6, and also the EliteDesk 800 G3. I'll put cards here to those videos in case you would be interested. But back to the ProDesk 400 G5. This is the tower version, and although the design gives the impression that you can also use it on the side, like a desktop model, there are no feet on that side of the case, so using it like this will most likely end up with a scratched surface. Other than that, using it on its side wouldn't really impact operation of the machine. On the front of the machine we can find a power button, headphone jack, 2 USB ports, a blank for an optional SD card reader, and a slim DVD drive which has the eject button hidden over here. On the back of the machine, we can find a power supply and connector, a PCIe card with 2 serial ports, the back of that GT 1030, 6 more USB ports, Ethernet, 2 times VGA, DisplayPort and audio. Opening up the case is easy and can be done by loosening the single thumb screw on the back and then slide the cover backwards in order to remove it. The SATA drives are mounted in a drive cage on top of the case. Here it only has a DVD drive, but there is more room for 2 additional 3.5-inch and a 2.5-inch drive. Let's first disconnect that DVD drive by removing the power and SATA cable. To get the drive itself out, we can just press the green lever here and then slide it out towards the front. Let me also take off the front cover. Now that we removed the drive cage, we can have a good look inside the case, and we can see the power supply here, the PCIe serial port card, GT 1030, CPU and cooler, memory, and the M2 NVMe drive. As you might see, as many of these branded Dell, HP or Lenovo desktops, this one as well doesn't have a standard ATX power supply and connector. To continue the disassembly, let's disconnect everything from the motherboard now, and let's start with the power command connector. Then the speaker, power out for SATA devices, which runs through the motherboard, the SATA cable for the DVD drive, power input and P4 power connector, then the CPU fan, and finally the system fan. Next I will remove the PCIe cards. First one to get out is that NVIDIA GT 1030. It looks like this is a passively cooled model from MSI. On the sticker we can see that it most likely has 2GB of VRAM. By changing the backplate, this card would also fit in a smaller form factor case as it clearly is a low profile card. The second card is providing those two serial ports. As far as I could see by the installed applications and also from the environment where I picked it up, this machine was probably used to do some CAD drawings and control CNC machines. So the need for serial ports definitely makes sense. Let me also get the memory out. Two modules of 8 GB for a total of 16. Now, before we can get the motherboard out of the case, we first need to remove the CPU fan, as it is connected to the bottom of the case through that board. There we go. The thermal paste seems to be in quite good condition. After all, this machine is not that old yet. Next step is to remove the screws that hold the motherboard in place. Now that is done, we can finally get the board out. There is not a lot of room to move the board, and the easiest is to lift it up slightly, then get it to the front of the case, which gives you enough space to lift it out. Before we take a better look at the board, let's also check out the power supply. As we can see, it can deliver up to 340 watt and it's qualified as 80 plus gold in terms of efficiency. Back to that motherboard now. Here we still have the M2 NVMe drive installed. By removing the screw holding it in place, we can easily get it out. This is a 512 GB drive from SK Hynix. And the last component to come out, but not the least, is the CPU. And indeed, as I mentioned, this machine is equipped with an Intel Core i7-8700. As the number tells us, this is an 8th generation Intel Core CPU, also known as Coffee Lake. It has 6 cores and 12 threads, runs at 3.2 GHz and can go even up to 4.6 GHz in Turbo Boost. Doesn't get much higher than that as far as I know. Power consumption, or TDP, for this processor is rated at 65 watt. We will need to keep that in mind for the upgrade with the GTX 1650, but I'll come back to that later. Let's have a better look at the motherboard in more detail now. We have the CPU socket here, 2 memory DIMM slots, a PCIe X16 slot and 2x X1, then connectors for power command, power input and P4 power input, SATA power out, system fan and CPU fan, header for serial port and PS2, speaker, SD card reader, M2 slot for NVMe and M2 for wireless, 3 SATA ports, CMOS reset button and CMOS battery. Before we put things back together, let's take a look at all components. We have the motherboard, DVD drive, PCIe serial port card, 2x8 GB of DDR4 memory, the i7-8700 CPU, cooler, 512 GB NVMe drive, and MSI NVIDIA GT1030. That GT1030 is what I will initially also put back, as I want to benchmark it first. After that I will replace it with this GTX 1650 OC from Gigabyte. And as you might have noticed, we will also need to take care of this 6-pin power input, but more about that during the replacement. Let's first put everything back together as it was. I'll start with putting back the CPU. To do so, we first need to open the socket, then we can simply insert the CPU and close the socket again. Next, I'll put back the memory, which we just need to insert in the 2 memory DIMM slots on the board. Then we can also put back the NVMe drive in the M2 slot and get it fixed. The rest needs to happen when the board is back in the case, so that's the next thing to do. Again, space is pretty limited, so it takes a bit of creativity to get everything back in place. Time to fix the board back to the bottom of the case now. And while there is still room around the board, I'll also put back all connectors where they belong. That's done. So a bit of fresh thermal paste is applied to the CPU, and we are good to boot back the CPU cooler, which I cleaned up earlier. After fixing the heatsink to the board, we shouldn't forget to connect the fan as well. Then it's time to put back the PCIe cards, starting with that GT1030, and then that serial port card. I'll also prepare to connect the DVD drive, so first the SATA cable and then the cable that will provide power. Before putting back the drive cage, I will first slide the DVD drive back in its place. And after routing the cables properly, we can also connect them to that same drive. We're as good as done here. We just need to close up the case. So first the front panel is reinstalled, and then we can put back the cover and fix the thumb screw that holds it in place. Ready for a first test now, and to check if everything still works as expected after the disassembly and reassembly. I'm pressing F10 here in order to force the system to enter the BIOS setup. Here we can have a look at the system information. We can see that 16 GB of memory is detected, the NVMe drive is present, and we still have our i7 8700 as CPU. In the same menu we also have some more information about the machine and installed firmware versions as well, but so far everything looks fine. As a next step, let me insert the bootable Windows 11 installation USB drive. Instruct the machine to boot from it, and then run through the Windows installation. Windows 11 is not officially supported on this hardware, so we'll need to work around the hardware checks here. I'll put a card here to another video where I covered this in detail, in case you would be interested. Once Windows 11 got installed, I also installed all available Windows and driver updates through Windows Update. This resulted in a BIOS update and Intel Management Engine update as well. Nice to see that this is properly integrated through Windows now. After plenty of reboots and patience, our system is finally ready. All updates are installed, as you can see, so let's take a look at About, where we obviously see exactly the same hardware as we could see in the BIOS setup. Time to start benchmarking. During this process I had some issues with my HDMI capture card, so what you see here is already the second time I run through the benchmarks. The first test, as I usually do, is the CPU benchmark in Geekbench 5. We get 1156 for single core performance and 5904 for multi-core. Pretty good result, and as you can see this is close to an earlier tested i7 9700, which was in this machine's successor, the ProDesk 400G6. It's also a very similar result to my upgraded Apple Mac Pro 4.1, at least in Geekbench 5. Next test is the compute test in Geekbench 5, which will test performance of that GT1030 GPU, which we still have here. 7700, that's not so great. And actually I think it's only around double the performance of what the integrated graphics can do. We'll see after upgrading to the GTX 1650 what difference there will be. Let me now repeat the CPU benchmark with Geekbench 6 as well. We get 1527 and 6320 here as cores. Interestingly, That's about twice of what we got on the Apple Mac Pro for multi-core performance. This was not the first time that I found these results with Geekbench 6 a bit strange, mainly comparing them with the results I got in Geekbench 5. After some reading, I understood that the way how multi-core scores are calculated makes more sense now. Previously, multiple tasks were created and measured, so the more cores you had, the quicker these tests would complete. In the case of the Apple Mac Pro, 12 cores of around 500 points results in 6000 points for multi-core. For this machine, 6 cores of around 1000 points resulted in a multi-core score of around 6000. In Geekbench 6, on the other hand, one single workload is used to measure multi-core performance, and all the cores work together on that one shared objective. This results in a more realistic multi-core score. And clearly, a modern single CPU is a lot more efficient in doing that than those two old Xeons. Cool to see what difference this makes, if you ask me. As I did in Geekbench 5, I will also repeat the GPU benchmark on the GT 1030. The result here is 7657. Now to test the performance of the NVMe drive, let me run AGA system test. (776 megabytes per second write and 1118 megabytes per second read. That's not too bad, but also not very good for an M2 NVMe drive. Probably though, unless you're really doing some heavy lifting, it won't really affect day-to-day performance much. Now to test how this machine, with the GT 1030, performs realistically in games, I will also be running 3D Mark. This takes some time, and looking at the stuttering and frame rate we get, we can already predict that the result won't be very good. And indeed, it is not. 741 is what we get as a result. Not really usable to play pretty much any recent game that is out there. So clearly it is time to replace that GT 1030 with the GTX 1650 as we planned from the beginning. As this GTX 1650 requires an extra 6-pin power input, I will use a SATA power to 6-pin PCIe adapter like this one. In general, I'm not a fan of these kind of adapters, as SATA power is not meant for the high currents that are sometimes required by GPUs. Especially not in this case, where all of that power even runs through the motherboard. But a standard GTX 1650 would draw up to around 75 watt only at maximum, which actually doesn't require additional power input. The reason that this specific GTX 1650 does have that 6-pin power input is because it's the OC or overclocked edition. That sounds fancy, but the difference with the standard card is really nothing spectacular. But due to this card being clocked higher, it requires a bit more than the 75 watt the PCIe slot can deliver, and hence we need external power. All in all, that additional power requirement is relatively low, so there isn't really a risk using a SATA power adapter in this case. Let's open up our case again, put the drive cage aside, and get the GT 1030 out. After that, we can just replace it with the GTX 1650 and get it fixed. Then we can connect that 6-pin power adapter and put the drive cage back where it belongs. As you can see, the room for that connector on the GPU is very limited, as the drive cage goes right above it. Fortunately, HP took care of that, and there is a cutout to deal with this. Let's see if we can still boot the system now that we have that GPU replaced. Seems like we're good. In the meanwhile, my capture card acted up completely, so I gave up on it and will need to do it with the video of the screen instead. Apologies for that. In Task Manager, we can see that the card got detected properly, and we can straight away redo the GPU benchmarking in Geekbench 5 to begin with. 41,402. Now that's a big difference with the earlier 7,700 we got with that GT 1030, and perfectly in line of other times I did a benchmark with this or any other GTX 1650. Let's do the same benchmark with Geekbench 6 now. $42,064. Again, a large difference as expected and in line with previous tests as well. To know how this GPU upgrade translates to more realistic game performance, let's also repeat the test I did with 3D Mark. Already while the test is running, we can see a much more fluent experience. That only gets confirmed once we get to see the results. 3,929 versus the 741 we got earlier with that GT 1030. Clearly, this makes a big difference. Again, this is perfectly in line with earlier machines where I did the benchmark with this card and similar CPU performance. But what better way to really test this card than playing some games? Let's start right away with a more demanding game, Microsoft Flight Simulator. Running on Full HD with medium quality. Looks like we get around the 40 frames per second, with some small drops sometimes when we get closer to more detailed areas, but very playable as you can see. Let's move to GTA 5 now. A bit older already, but still a lot of fun to play and great to test this hardware. This is how I got this setup. Resolution on Full HD and pretty much everything on high and very high with proper AA. When running the benchmark in the game, we can see that the performance is going around 100 FPS or sometimes even higher, depending a bit on what needs to be rendered. When actually playing the game, we see that this is reflected here as well. The frame rate almost never drops under 100, and you can see that everything is super fluent and looks really good. That's all I got for this video. This machine got a nice upgrade by installing that GTX 1650, and performance in general is pretty good overall. Not a surprise of course, as this is about the fastest CPU possible in this machine. Further upgrading the graphics performance will be hard though. Newer and faster GPUs will require dedicated additional power input from the power supply, which we simply do not have here. So, to my ID, a GTX 1650 is about the best you can get in this ProDesk 400 G5. Not a big punishment, as gaming definitely works fine with the setup, as you could see. Thanks a lot for watching, I hope you have enjoyed this video, and if you did, I'd appreciate a thumbs up, and don't hesitate to subscribe to my channel if you're interested in more of the same. Thanks again, and hope to see you back here soon.